let us look at the next section, students. This section contains 3 integer type questions. The answer to each of the question is a single digit integer. So let us look at question number 38 now. Consider the following reaction. So students, in the reaction, the examiner seems to be interested in the coupling of benzene diazonium salt with beta naphthol. And the examiner is interested in knowing at the position number at which pH N2 plus attacks to form the major product. So students, the electrophile will attack the more activated ring, which is the ring containing the OH group. And if we look at the sites which are capable of accommodating the incoming electrophile, there is a competition between position number 1 and position number 3. And out of these 2 positions, we can see that the position number 1 is more suited for the incoming electrophile, as it has a conjugation of this benzene ring as well. So students, the incoming electrophile will attack beta naphthol at the carbon number labeled as 1. So we have to mark 0, 1 as the correct answer to our question. Moving on ahead to question number 39. How many of the given acids are stronger acid than phenol? So phenol has a pK of around 10. So we have to find the acids which are stronger acids than phenol. So we have a triangular acid. Triangular acid has the structure. So it has equivalent resonating structures. So does squaric acid. Picric acid is also a stronger acid than phenol. The 3 NO2 groups which are attached shall enhance the acidity of this OH bond. Salicyldehyde. Salicyldehyde also has a electron withdrawing group present on the benzene ring, which is going to stabilize the phenoxide ion which is left behind when this H is ionized. So if you look at salicylic acid, salicylic acid also has a lesser pK than phenol. The carboxylic acid group will be much more acidic than the phenol group. We can look at metacresol and paracresol. So metacresol and paracresol will not be more acidic than phenol because the CH3 group attached shall decrease the acidity. So this is not a stronger acid than phenol. This is also not a stronger acid than phenol. Anisole. Anisole does not have an acidic hydrogen. Anisole is OCH3. Formic acid has a pK of around 4. So it is also stronger acid than phenol. Acetic acid is also stronger acid than phenol. The carboxylic acids are stronger acids than phenol, and the sulfonic acid are SO3H. These are even stronger than the carboxylic acids. So students, out of these given molecules, we have 3 molecules which are not stronger acids than phenol, while the other 8 species present are stronger acid than phenol. So students, we have to mark 08 as the correct answer to our question. Let us look at the next question. Question number 40. Some of the statements are given below. How many statements are correct? Bakelite is an example of thermosetting polymer. This statement is correct, students. Bakelite is formed when novolac is allowed to undergo further cross-linking with formaldehyde. So the polymer formed is a thermosetting polymer in the end. Buna S is a chain growth polymer. This statement is also correct, student. Buna S is formed by the addition polymerization of butadiene and styrene. So it is a chain growth polymer and not a step growth polymer. It is not a condensation polymer. Caprolactam on heating with water produces nylon 6 polymer. Yes, students, this is correct. Caprolactam on hydrolysis, it undergoes ring opening and which on further polymerization forms the nylon 6 polymer. Let us look at option D now. Terylene is a polyester polymer. This statement is correct. Terylene or dacron is formed by the polymerization of terephthalic acid and ethylene glycol. So this is also correct. Let's look at statement E now. One molecule of melamine contains 6 lone pair of electrons. We can look at the structure of melamine. Melamine contains alternating carbon and nitrogen atoms in a ring. And each carbon has a NH2 group attached. So if we count the number of lone pairs present, each nitrogen on this molecule has 1 lone pair each. So it contains 6 lone pair of electrons. This is correct. Let us look at option F now. Glucose on oxidation with Br2 water produce saccharic acid. This is incorrect. Glucose produces gluconic acid on reaction with bromine water. To form saccharic acid, we need HNO3. So bromine water will form gluconic acid. Maltose is a reducing sugar. Yes, students, this statement is correct. Maltose is a polymer of glucose. And since glucose is reducing, maltose will also be reducing. Let us look at statement H now. A tripeptide contains 3 amino acids connected with 2 peptide bonds. This is correct, students. Tripeptide means there are 3 amino acids. And to connect 3 amino acids, we'll need only 2 different peptide bonds. So this is correct. Vitamin C is water soluble. Yes, students, this statement is also correct. Vitamins A, D, E, and K are not water soluble, whereas the other vitamins are. So if we look at the statements given to us, we have 9 statements, and out of these 9 statements, only one is incorrect. So students, we have to mark 08 as the correct answer to our question. So this is it for today, guys. I hope the solutions were clear to you.